Welcome friends, back to another episode of Class 12th Maths by Sanjay Agarwal. So, today's topic is vector or cross product of two vectors. Alright, so we have already done dot, which is also called scalar, dot product of two vectors, where my answer after multiplying the two vectors is a number, a scalar. Now my answer will be a vector. So let me get my chalk and start the lecture for today's class. So I tried writing on a whiteboard with a marker pen. That doesn't give that tuck 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 sound of my chalk hitting the blackboard, but somehow that's not good for my throat. The fumes coming from the pen are harmful. So I have no option than to continue with the chalk on a green board. So what is our today's topic? Cross product of two vectors. Cross product is also called vector product. Why it is called cross product and why it is called vector product? Let us see. You see, when you are multiplying two vectors, you have to put something between the two. You just can't write them side by side. Of course, reduce the gap. That is wrong expression altogether, doesn't mean anything. So you have to put something, and the options are two. Either put a dot or you put a cross. When you put a dot, the answer is a number, a scalar. We have already covered that. Here we are going to put a cross. So when I put a cross, it is called cross product of two vectors. And since my answer is a vector, you may also like to call it as vector product of two vectors. So both means the same thing. So you call it by any name, cross product or vector product. Now when I multiply A and B with a cross in between, my answer will be a vector. When my answer is a vector, it has two things associated with it. That's the difference between scalar quantities and vector quantities. Vector quantities have two informations associated with it, a magnitude and the direction. So every vector has the magnitude which by default is always a positive number and a direction. So let's first find about what is the magnitude of this vector. So let me make a chart like this. So it will have two things, or let me represent it in a different manner. So A cross B will have a magnitude and a direction. Why? Because it's a vector product, answer is a vector. And if I put dot here, then I only have magnitude, and that is why dot product is easier as compared to the cross product, because here I have to deal with direction as well. So let us write, I am not deriving it, that's why I am writing the word write. Let us write the magnitude of vector A cross B. So it will be like this. Magnitude of A cross B, this is a symbol for magnitude of A cross B. This is also called modulus symbol, but when I apply the same modulus symbol on vectors, it is called magnitude of the vector. Some of you may like to call it mod also. So magnitude of A cross B का formula आपका, so this is the formula, magnitude of vector A, magnitude of vector B into sine of angle between them. Magnitude of the vector, any vector is always a positive number. Magnitude of A is a positive number because it's magnitude, so is magnitude of B. What about sine theta? You know what the limitation is on theta? Theta is always between 0 and pi, inclusive of both 0 and pi. That means theta is in the first quadrant or in the second quadrant, and both the quadrants, first and second, sine theta is always positive. So I don't have to worry that this number can go negative. Cos theta can go negative when angle is between pi by 2 and pi, that is in the second quadrant, but sin theta stays positive. So be rest assured this expression will never be negative because the magnitude of the vector can never be negative. So this is the first formula you have to remember. Cross product of two vectors is a vector which is written as A cross B, and its magnitude is magnitude of A, magnitude of B into sin theta. Theta is the angle between vector A and B. Okay. From this you can make another formula. What is the sine of angle between two vectors? So sine of angle between two vectors is magnitude of A cross B divided by magnitude of A, magnitude of B. This is not a new formula, you just rearrange the main formula. So this becomes the backbone of your cross product formula. So magnitude is done. Had it been dot product, my theory was almost over. But since it is a vector, let's talk about direction. So what is the direction of this vector A cross B? Alright, so once you write this, I will rub it off and then we will talk about direction of vector A cross B. So let me quickly speak about this again. I have vector A, I have vector B, I want to multiply them, I put a cross, dot we have already done. When I put a cross, it is called vector or cross product, answer will be a vector. If answer is a vector, it will have magnitude as well as direction. What will be the magnitude of A cross B? You put these vertical symbols. Magnitude of A cross B is magnitude of A, magnitude of B into sin theta, where theta is the angle between two vectors and this sin theta will always be positive. You rearrange this formula, you get another formula. Sin theta is magnitude of A cross B divided by magnitude of A and magnitude of B. I am sure this will go in your head, absolutely no problem. It is a very small concept. And what about this formula? This you will have to remember. So magnitude of A cross B is magnitude of A, magnitude of B into sin theta. Now let us talk about the difficult portion of this. What is the direction of A cross B? Okay, so before I dive into this, how do I find what is the direction of A cross B? Let us talk about three very interesting lines you should remember. Alright. 2 points are always collinear. Means you can draw a straight line passing. Alright, I am not very sure about the spelling of collinear, I hope it is right. So 2 points are always collinear. 3 points are always coplanar. See, this surface of the blackboard is a plane. You put any 3 points, you will be able to draw a plane. If I put it here, obviously they are coplanar. But if I mark 3 points in the space, look at the tip of my finger, 1 point here, second point here, third point here, we can we'll be always able to make a plane passing through those 3 points. Of course, we may not be able to draw a line passing through 3 points. Even here you can see, if I draw a line passing through these 2 points, it will not pass through this. But 2 points, any 2 points you mark, you will be always able to draw a line passing through them. That's why I say 2 points are always collinear, and 3 points may or may not be collinear, but they will obviously, and every time they will be coplanar. So please do remember that 3 points are always coplanar. And now comes the catch. 2 vectors are always coplanar. Please do remember it. 2 vectors are always coplanar. So you see, this is vector A and this is vector B. So they are on the same plane. Now if I have a vector A, look at this finger here, I have vector A and this is vector B. They are not coplanar. But if I move this vector and bring it here, see, vectors can be moved freely in the space as long as you don't change their magnitude and direction. So this is the magnitude of the vector, this finger. If I take it anywhere, anyway, my finger is not becoming longer and shorter, and I don't change my direction. So this is vector A, this is also vector A, this is also vector A, this is also vector A. So this is vector, one vector, this is another vector. Right now they are not coplanar, but I can move them. Now like this. So now I can I can keep the page of my exercise book like this. So one vector here A, one vector here B. So two vectors are always coplanar. So please remember these three lines you should write in your exercise notebook. You should make a separate notebook where you should write the theoretical concepts and make a separate notebook for doing your numericals. Don't mix both of them. So it is always advisable to make a theory notebook where you just write the theory. In that theory notebook, put a box and in deep red color write these three lines. They will be used very often. 2 points are always collinear, 3 points are always coplanar, and 2 vectors are always coplanar. Now, if I say, listen to me, there is a vector, say vector R, okay? There is a vector, say vector R, such that vector R is perpendicular to vector A and also vector R is perpendicular to vector B. So I have some arbitrary vector, I call it as vector R, which is perpendicular to A and at the same time it is also perpendicular to B. Then I can also say vector R is perpendicular to plane containing vector A and vector B. So if vector R is perpendicular to A and vector R is also perpendicular to B, and A and B, you know, two vectors are always coplanar, then vector R will automatically be perpendicular to the plane containing A and B. Alright. So let me draw a diagram here. See, I have drawn a plane. This is vector A, this is vector B, both the vectors are coplanar. My vector, suppose this is a vector R. Now this chalk, you can see in my hand, the holder. So this vector R is perpendicular to A. So you can see here, so vector R is perpendicular to A, vector R is also perpendicular to B. So you can see that vector R is perpendicular to the plane containing A and B. See, this parallelogram I have drawn is a plane which contains vector A and vector B. My vector R is perpendicular to A. My vector R is also perpendicular to B. Then it is perpendicular to the plane containing A and B. So when I say this line, please remember it again. 1, hashtag I am going to put 2, 3 and 4. So suppose there is a vector R which is perpendicular to vector A as well as vector B, then it is automatically perpendicular to the plane containing A and B. So that will be this vector. So it can be coming above or it can be going down. In both the cases, vector R is perpendicular to the plane containing A and B. So when it could be like this, coming outside the blackboard, it could be like this, going inside the blackboard. Either way, this chalk holder is perpendicular to this plane. Here it is pointing inside, here it is pointing towards you. So I'll again repeat these 4 points and then I'll move on to the direction of the vectors. So 2 points are always collinear, 3 points are always coplanar, 2 vectors are always coplanar. If there is a vector R which is perpendicular to vector A as well as vector B, then it is automatically perpendicular to the plane containing A and B. Conversely, if vector R is perpendicular to the plane containing A and B, obviously it will be perpendicular to A separately as well as perpendicular to vector B. Now I am going to come to the direction of A cross B. So I will rub off the blackboard. I hope you have already written it and this is in your head. it must sink in your head because I am going to use it very often. Okay, 2 points are collinear, I am not going to use, that's we have been using since our lower classes, but 3 points are coplanar, I will be using it in coordinate geometry. 2 vectors are always coplanar, I will be using it in vectors now. Now I come, so this was the groundwork I did for what I am going to now make you understand what is direction of vector A cross B. So see here, direction of vector A cross B is such that, see now, this you have to remember, direction of vector A cross B is such that it is perpendicular, this is a symbol of perpendicular, perpendicular to vector A as well as perpendicular to vector B, or you can say it is perpendicular to plane containing vector A and vector B. So what is the direction of A cross B? So A cross B is a vector which is perpendicular to A as well as B, or it is perpendicular to the plane containing A and B. So now you know that A cross B is a vector. What is its magnitude? Magnitude of A, magnitude of B into sine theta. What is its direction? The direction of A cross B is such that it is perpendicular to A vector, perpendicular to B vector, or simply you say it is perpendicular to the plane containing vectors A and B. Vector A and B will always be coplanar. So let's take a यूनिट वेक्टर, उसको मैं सिंबल दे रहा हूं n कैप. लेट्स टेक ए यूनिट वेक्टर n कैप which is perpendicular to plane containing A and B. तो आज हम एक we are introducing a new vector, a unit vector n cap means it's a unit vector which is perpendicular to the plane containing A and B. So we'll call this now as n cap. It could be in this direction, it could be in the bottom direction. Alright. So now I will give a complete definition of A cross B. Right now I gave the definition of A cross B in 2 parts. First part was magnitude, second part was direction. Magnitude is magnitude of A, magnitude of B into sine theta, and direction is such that it is perpendicular to the plane containing A and B. Now let me combine both the information and give you one single formula. So I am going to rub it off. I hope you have already written it. Alright. So let's introduce a new vector with the symbol small n with a cap on it, signifying it is a unit vector which is perpendicular to the plane containing A and B. Now I am going to rub it off, and now I am going to give you a complete definition of A cross B, where I will not have to speak anything, the formula will speak for itself. A cross B, what is the formula of A cross B? Magnitude of A, magnitude of B, sine theta, put a bracket into, but you don't put a symbol here, n cap. So this is the definition. A cross B is magnitude of A, magnitude of B into sine theta. This will be a number which will be a positive number multiplied by n cap. What is n cap? I have already defined to you what is n cap, where I can write it again for you, where n cap is a unit vector perpendicular to vector A and also perpendicular to vector B, or n cap is perpendicular to plane containing vector A and vector B. There is one more thing, such that vector A, B and n cap form a right-handed system. Now you will be wondering what suddenly sir has spoken now. What is this thing such that A, B and cap form a right-handed system? This really doesn't make any difference. Even if you forget it, no numerical will be using it, but still I am going to explain to you. So now in this expression on the right hand side, although it's not in terms of ijk, but it gives me both the informations. What is the magnitude of A cross B? It will be magnitude of A, magnitude of B sin theta. And what will be the direction of this vector? Direction of this vector will be same as the direction of this vector, and this vector we have already defined. Vector n cap is perpendicular to A as well as B, or to perpendicular to the plane containing vector A and vector B. So A cross B is the vector whose direction is perpendicular to the plane containing A and B. A cross B is a vector whose magnitude is magnitude of A, magnitude of B into sin theta. So simple it is. Now what is this right-handed system? So see here, this is vector A, this is vector B. Alright, if I am doing A cross B, okay, so let me make them touching here. So you will start from A, go like this and stop at B, not like this, alright, because the angle between vectors is not more than 180 degrees. So you have to move in that region only where the angle between the vectors is. Alright, now you can keep your hand at A, right hand, that's why I call it is a right-handed system. But what I am explaining now is just for theoretical interest. In 12th maths, no numerical will be using this information. You keep your fingers at vector A, right hand, you keep your palm like this, curl your fingers in this direction, A to B, and stretch your thumb. So this is A cross B. So here your vector which will be perpendicular to this green blackboard will be coming out. Alright, so let me put a dot here. So this is it. So this is A cross B. Keep your right hand on A, curl your fingers towards B, stretch your thumb, and this is A cross B which is perpendicular to the blackboard and coming out of the blackboard. Now let us take B cross A. This is called forming a right-handed system. Okay, let me draw the same diagram. A, B. Now since you are doing B cross A, you will start your arc from B, go like this and terminate it on A. Don't go like this, okay, because this is not the angle between the vectors. Angle between the vectors is not more than 180 degrees or pi. So now keep your fingers at B, okay, and keep your palm, I will not say fingers, keep your palm at B, curl your fingers towards A. So if you do it like this, you are going to break your fingers. Alright, so you keep your hand like this on B, curl your fingers towards A, stretch your thumb. So now this is it. So this is going inside the blackboard. So B cross A will be a vector which will be perpendicular to the plane containing A and B, but it's going inside the blackboard. So I can show it like this with a cross here. This is like tail light of the car, this is like headlight of the car. So here the car is coming like this. That is A cross B. Here the car is going inside the blackboard. So what you are going to see is the tail light of the car. So that's why I put a cross here. So it's like this, right hand on B, curl your fingers towards A, stretch your thumb, and that gives you B cross A. So in either way, whether it's A cross B or B cross A, both the vectors have the same magnitude. A cross B will be magnitude of A, magnitude of B sin theta. B cross A will be magnitude of B, magnitude of A sin theta. Both will be same. Both will have directions perpendicular to the plane containing A and B, but there will be a difference. One will be coming out of the blackboard and one will be going inside the blackboard. So I get a formula from here. A cross B is not equal to B cross A. In dot product it was. A cross A dot B was equal to B dot. So what is the correct answer? A cross B is equal to minus of B cross. Both have the same magnitude. The direction of A cross B is coming outside the blackboard, direction of B cross A is going inside the blackboard, but if you put a minus sign, the direction becomes opposite. So look at this chalk, this is the pointer, So this is B cross A. When you multiply it with minus, it will become minus of B cross A. So it will become in this direction same as A cross B. So you have to remember this. So dot product was commutative, A dot B was equal to B dot A, but vector product is not commutative. A cross B is equal to B cross A. Alright. Okay. So now the foundation of cross product is laid. So let me again quickly summarize. A cross B is a vector whose magnitude is magnitude of A, magnitude of B into sine of angle between them. The direction of A cross B is in a direction which is perpendicular to A as well as vector B or to the plane containing vector A and B, because two vectors are always coplanar. So we define a vector of magnitude 1, give it a symbol small n, put a cap on it which signifies it's a unit vector. So n cap henceforth in this chapter will mean a unit vector perpendicular to A as well as B or perpendicular to the plane containing A and B, which is the direction of A cross B. So the combined formula of A cross B will be this. A cross B will be magnitude of A, magnitude of B, sine theta into n cap. You don't put any dot and cross here. Dot and cross are put between two vectors, not between a number and a vector. This is the number. Magnitude A is the number, magnitude of B number, sine theta is the number. You multiply three numbers, you get a number. So you can't put dot across here. Be very careful about that. Alright, the moment you put dot across here, it becomes meaningless. But when you have two vectors and you don't put anything between them, then that is meaningless. It's so funny. So between a number and a vector, you can't put anything. But between two vectors, you have to put something, either dot or cross. So A cross B is this. So this portion, A cross B, vector will be coming outside the blackboard, B cross A, vector will be going inside the blackboard. Both the cases, it will be perpendicular to the same plane. Only thing is their direction will be opposite. So that gives me the first formula. After I finish my basic formula, A cross B is equal to minus of B cross A. Let me rub this off and we continue our theory. You must watch all the video lectures one after the other and don't give a gap. One today, one tomorrow, or maybe two lectures in the same day, because if you give a big gap, you will forget what you have studied in the previous lecture and then there will be a problem in understanding it. So I also will be uploading almost all the classes one by one every day, so that a continuity is maintained and you are able to complete a chapter without forgetting what you did in the previous class. If you put a lot of gap, then by the time you look at the next video, you would have forgotten everything what you did in the previous, what you learned in the previous lecture. Now, suppose, how do I find a unit vector perpendicular to vector A and vector B, or perpendicular to plane containing vector A and vector B? This is my question. Let me draw a diagram for you. This is the plane. This is vector A. This is vector B. You want to find a unit vector perpendicular to the plane containing vector A and B. Again I will repeat, two vectors are always coplanar. So what you are going to do? How do I find a unit vector perpendicular to A and B? What you do is, you first find A cross B. Now you must be expert in this. What is A cross B? It is a vector which is perpendicular to both A and B. That is, to the plane containing A and B. But this vector will have certain magnitude. What will be this magnitude? This one. But I don't want any arbitrary magnitude. I want magnitude as 1. So what I am going to do is, I am going to divide this vector by its own magnitude. So you replace A cross B by this. Magnitude A, magnitude B, sine theta. And that is the formula. What is magnitude of A cross B? We already wrote it. What was it? Magnitude A, magnitude B into sine of angle between the vectors. So they will cancel, only n cap will remain. So this is it. So this is the formula of unit vector which is n cap, is a unit vector perpendicular to A as well as B or to the plane containing A and B. So that will be A cross B divided by its own magnitude, or you can even put a plus minus, because you can have two possible answers. I'll show you how. See here, one is coming outside the blackboard and one is going inside the blackboard. So when it is coming outside the blackboard, that will be a plus symbol, going inside the blackboard will be your minus symbol. So either you write your answer with only plus, or you write your answer with plus or minus both. Alright. So that finishes one part of your cross product. The class is becoming lengthier. You might be feeling sleepy or tired by this time. So there will be another episode or a lecture from where I'll carry forward. We'll talk about the properties of cross product, and then we're going to talk about the real thing. When the vectors are expressed in terms of ijk, how exactly I find A cross B. So that will come in the next lecture. So I hope you enjoyed the class, and don't forget to give your comments, and of course if you wish to continue with such more lectures, you don't want to miss them, obviously you will be subscribing to the channel and also hitting the bell button.